Hello everyone, welcome to the next video on extra skills practice. In this video we're going to be looking at solving equations. So for the first three, they are quite basic, so we're just working with these as a nice recap and we'll move on to some more difficult ones. So 3y plus 12 is equal to 19. I'm going to start by moving this 12. So I'm going to do the opposite. So I'm going to take 12 from both sides. So I'm going to be left with 3y on this side, and then 19 minus 12 is 7. Now I've got 3y, I want 1y, so 3 lots of y here, I need to divide by 3. So divide by 3 on both sides, I'm going to have 7 over 3. Let's move to this one. Now, there's two methods for this one. I'll do method 1. Because there's a minus x, you could move the minus x onto this side, and then it will be positive and nicer to work with. So I'm going to add x to both sides. So I'm going to have 6 is equal to 2 plus x. Now I'm going to move this 2, so it's positive. So minus 2 from both sides, I will be left with 4 is equal to x. You can write it as that, or x is equal to 4. Doesn't matter, it means the same thing. Method 2, if you don't like that method as much, I can just work with the minus x. So I'm going to go back to here and take 6 from both sides. This is a positive 6, so let's take 6. I'll be left with minus x is equal to minus 4. And then I want a positive x, not a negative x. So I need to divide by minus 1. So dividing both sides by minus 1, I get x is equal to 4. Let's move to this one. We've got an unknown on both sides. So for this one, I'm going to move the 2x to the 5x because this is larger, so it will avoid me having a negative x. So minus 2x from both sides, I'm going to be left with 8 is equal to 3x. Now I want to divide by 3 on both sides, so x is equal to 8 over 3, and then we're done. By all means, you can start changing that, so you can write it as x is equal to 8 over 3. Alright, let's move on to some other ones. Now here we've got some brackets. You may think, right, we'll expand out and then we'll solve that. But if you expand out, you've got 5t minus 5, and then you've got to move the 5 over and then divide by 5. It's actually making it longer by expanding out. So let's leave it in this simplified form and think, well, this could be 5y is equal to 20. And then we just divide both sides by 5. So let's do that. Let's divide both sides by 5. So we're left with t minus 1 on this side. I don't need the brackets anymore. And 20 divided by 5 is 4. Now let's work with the minus 1. I'm going to add 1 to both sides. So t is equal to 5. This one, 2x plus 4 divided by 3 is equal to 7. We need to work with the denominator here. This actually means 2x plus 4 divided by 3. So if I multiply both sides by 3, I'm going to cancel this denominator here. So if I multiply by 3, I'm just going to be left with 2x plus 4 on that side. And then 7 multiplied by 3 is 21. Now I want to move this 4, so minus 4 from both sides, 2x is equal to 17. And then the final step, just divide both sides by 2, 17 over 2. And I can leave it like that, or change it to a decimal because the decimal is quite nice. Now here we've got a similar case as the one we've just looked at, but this time we've got an expression on the denominator. We can still do the exact same process and multiply by the expression. So I've got a divide by x plus 1 here, so let's multiply everything by x plus 1. So I'm going to be left with 4 is equal to 3 multiplied by x plus 1. I'm going to have to use the brackets here because I need to make sure that 3 will be multiplied by that expression. Now, we could look at the same process as we did here and not expand out, but we're going to get 4 over 3 and then it's going to be a little bit difficult to work with when we've got to move the 1. So I'm actually going to go ahead and expand that quickly. And then I'm going to move the 3 over, so a minus 3 from both sides. I'm going to have 1 is equal to 3x. And then I'm going to divide both sides by 3. So I'll start with the x on this side. X is equal to 1 over 3, which is a third. Let's move to this one. We've got 5x minus 7 divided by 2 minus 3x. So again, I'm going to use the same process as the one I've just done over there and multiply both sides by 2 minus 3x. Now, I've got a 0 here, so 0 multiplied by this is going to be 0. Because remember, anything multiplied by 0 is 0. So I'm just going to have a 0 here. Then let's work with the minus 7. So I'm going to add 7 to both sides. 0 add 7 is just 7. And then I'm going to divide both sides by 5. So I'm going to have 7 over 5. Let's move down a little bit and look at these two. Now, I've got two algebraic fractions over an equal sign. Now, you may have seen questions like this, and you may be very familiar with the method. The method I'm going to use is called cross multiply, where you multiply this numerator by the denominator over there, and this by that. Now, the reason why we can use this method is it's practically the same as what we've done up here and previously. It's because what we would do is we'd think, right, we've got to divide by 2x minus 1, so let's multiply everything by 2x minus 1. So the 2x minus 1 will go up here. And then we've got to divide by 4x minus 3, so then we need to multiply everything by that. So then the 4x minus 3 would go here, and remember this is gone now. So that's what we're doing, we're just cutting out a couple of steps. So 2 multiplied by 4x minus 1 on this side, minus 3, and 3 multiplied by 2x minus 1 on this side. And if you feel like you want to go ahead and do the longer version, you should still get to this step. So now I'm going to expand out. I'm going to have 8x minus 6 is equal to 6x minus 3. Then I'm going to move this 6x over here so it can combine with the 8x. So minus 6x from both sides. 2x minus 6 is equal to minus 3. And then I'm going to move this minus 6. So 2x is equal to 3. Minus 3 add 6 is 3. And then I'm going to divide by 2. Okay, so we've got 3 over 2 there. Let's have a look at this one. Now, there's two methods for this one, because you may see these algebraic fractions as similar to numerical fractions, where you think, hang on, I've got an addition here, and when I add fractions, I just need to make sure that the denominators are the same, and then I can add the fractions. So you could go ahead and find a common denominator, which in this case will be 6, manipulate the numerators, because remember, whatever you do to the denominator, you need to do to the numerator, and then add them and work out this. I'm going to do a slightly different method, which is the same process as what we've been doing previously. So here I've got to divide by 2. So I would be multiplying everything by 2. Remember, you multiply each side by 2, which includes this term here. So this term needs to be multiplied by 2 as well as that. But here I've got to divide by 3. So I would have to multiply both sides by 3 as well. So this would need to be multiplied by 3 as well as this. So really I'm doing a multiply by 2 and then a multiply by 3. Well, multiply by 2, multiply by 3 is just the same as multiplying by 6 all at once. And that just means that it's cutting out a couple of steps. Because if I multiply by 6 all at once, I'm getting rid of both fractions at the same time. So let's start by doing that then, and I'm going to break it down. So the first fraction multiplied by 6 is going to be 6x over 2. Remember, when you're multiplying fractions, the part that you're multiplying by goes on the top. Then we're going to have 6x over 3, which is equal to 60. Now I can simplify these, so I'm going to get 3x plus 2x. 6 divided by 2 is 3. 6 divided by 3 is 2, equals 60. Now let's combine these two, so I'm going to have 5x is equal to 60. And then dividing both sides by 5, x is going to be equal to 12. Now again, if you are not as familiar with that method and you want to look at the common denominator method and adding the fractions, work through it. So you could pause the video and you should still be able to get to x is equal to 12. Let's have a look at this one. We're getting a little bit more complicated now. So again, you can work with a common denominator and do it that way. You'd have to do a bit of cross multiply once you add these two fractions. I'm going to work with the same process as before. So again, you could look at multiplying everything by 3, then multiplying everything by 2, and then multiplying everything by 4 to get rid of all the fractions, and then you'd have some expressions to work with on the numerators. That's absolutely fine, but it's going to take 3 lots of steps. I'm going to think about what I can multiply by all at once. So yes, 3 multiplied by 2 is 6, and then 6 multiplied by 4 is 24. 24 isn't sort of the lowest number I could choose. You almost want to be thinking about the lowest common multiple of 3, 2 and 4. Well, that's going to be 12. So I'm going to multiply everything by 12. And that will make sure that all the fractions are going to disappear. So 12 multiplied by 2x over 3, add 12 multiplied by x plus 3 over 2 is equal to 12 multiplied by 3x minus 1 over 4. Now let's simplify. 12 divided by 3 is 4, so I've got 4 lots of 2x. 12 divided by 2 is 6, so 6 lots of x plus 3. And 12 divided by 4 is 3, so 3 lots of 3x minus 1. Now we're going to have to expand out, so I'm going to have 8x plus 6x plus 18 is equal to 9x minus 3. Let's combine. So 8x add 6x is 14x. Add 18 is equal to 9x minus 3. I'm going to move this 9x over and combine it with the 14x. So I'm going to minus 9x on both sides. 5x plus 18 is equal to minus 3. Now I'm going to minus 18 from both sides. So 5x is equal to minus 3 minus 18 is minus 21. And then x is going to be equal to minus 21 over 5 when we divide both sides by 5. And I can leave it as that. So again, if you have another method in mind, that's absolutely fine. Just make sure you are getting to the same answer as me. Let's have a look at this one. Now, again, I can start by multiplying everything by 2x plus 1 and 3x minus 1. Because they are expressions this time, I'm just going to have to go ahead and do that. Another method we can still use is the common denominator method, and I'm actually going to use that one for this one, just to mix it up a little bit. And if you are more familiar with that method, I'm still sort of working with you on this one. So the common denominator of these two fractions is going to have to be 2x plus 1 multiplied by 3x minus 1. Because they're expressions, that is what's common. So I'm going to write both fractions as that. Now, because I've multiplied this fraction here, the denominator, by 3x minus 1, I need to do the same to the numerator. So I'm going to multiply the 4 by 3x minus 1. And here I've got a minus. I've multiplied this denominator by 2x plus 1. So I'm going to have to do the same to the numerator. So I don't really need to include that bit. I'm still going to put it in brackets though. And remember, it's over 2x plus 1, 3x minus 1. So now I've got two fractions that I can take away. And think about it numerically. We might have 5/8 minus 3/8. And I want to work out what that is. Now I'm going to add in another step here because it's a little bit more complicated than this one. I'm going to combine the two fractions by doing 5 minus 3 over 8 and then working out what that's going to be. So we know straight away that can reduce to 2/8 and then simplify to a quarter. So I'm going to do that here. I'm just going to add on the equals 5 so we don't forget it. And let's combine these two now. So I'm going to have 4 lots of 3x minus 1 minus 2x plus 1. It's important to leave this in brackets because we've got a minus here, so we need to be careful with the sign. So now I'm going to have 2x plus 1 over 3x minus 1 is equal to 5. Now I'm sort of back to examples we've already looked at, and I can think about this as being a divide by 2x plus 1, 3x minus 1. So I'm going to get rid of this fraction now by multiplying both sides by this denominator. So if I multiply everything by these two brackets, I'm going to get rid of this fraction, but these two brackets are going to appear over here. So I'm going to have 4, 3x minus 1 minus 2x plus 1 is equal to 5 lots of two of the brackets. Let's extend the page a little bit. So I'm going to expand everything out now. So I'm going to have 12x minus 4 minus, remember this is almost like a minus 1 here. So I'm doing minus 1 multiplied by 2x, which is minus 2x. And then minus 1 multiplied by 1, which is going to be minus 1. Be careful here. A lot of people will just keep that as a plus 1, especially if you've not wrote it in brackets. is equal to, now I'm going to leave the 5 there and expand this out. We've looked at expansion already. This is going to become a quadratic. So I'm going to have 2x multiplied by 3x, which is 6x squared. 2x multiplied by minus 1 is minus 2x, and then 3x will be here. So minus 2x add 3x is just x. And then I'm going to have a minus 1 because 1 multiplied by minus 1 is minus 1. So next, let's have a look at what we can do. I can collect the like terms here. So I'm going to collect the x's. So I'm going to get 10x, and then minus 4 minus 1 is minus 5, is equal to 5 lots of 6x squared plus x minus 1. Now I can start by expanding this and then moving everything over, but I've just spotted something. You may have spotted it too. It's like the very first about fourth example we looked at where we had a 5 brackets t minus 1. So instead of multiplying everything out, which is going to just get larger, I've just spotted over here that 10x minus 5 will divide quite nicely by 5. So I'm going to actually divide both sides by 5 to get rid of this 5 and make this a little bit more simple. So divide everything by 5, I'm going to get 2x minus 1 is equal to, this is gone now because I've divided by 5. Now I'm just going to rearrange, so you can move these over here or these over here. I'm going to move these over here because I want a positive x squared to work with. So you almost think of it as sort of 0 is equal to that. So I'll just write it like that for the time being. So let's move the 2x over. So minus 1 is equal to 6x squared. Now it's a positive 2x, so minus 2x on both sides is going to be minus x minus 1. And then I've got this negative 1 to work with, so I need to add 1 to both sides. So 0 is equal to 6x squared minus x. Well, they're going to cancel. Minus 1 add 1 is 0 there, so I haven't got any constant anymore. I'm just going to rearrange this because it looks a bit funny that way around. So 6x squared minus x is equal to 0. Now, just a thought. If you were to expand this out and then collect the like terms and move everything over, you should still have got to this step. So you can follow that and make sure you've got to this part here. Now, 6x squared minus x is equal to 0. We're almost solving this now. It's an equation that we need to solve because it's equal to 0. So I can actually see a common factor in these two terms. There's an x common. So I'm going to factorise. I'm going to take an x out, open the bracket, and then x multiplied by 6x will give me 6x squared, and then x multiplied by minus 1 is equal to minus x, and then that's going to be equal to 0. So now we are looking at this and thinking what would equal 0. Well, when we multiply these two together, so when you multiply x by 6x minus 1, the answer is 0. So that must mean that either x is equal to 0 or 6x minus 1 is equal to 0. Because remember, to make 0, something must be multiplied by 0. So either this whole bracket equals 0 or this x is 0. So when we multiply it together, our answer is 0. Well, straight away, x can be equal to 0. Or we need to work out what this x can be. So again, just work through it. I'm going to add 1 to both sides. So 6x is equal to 1. And then divide by 6. So x is a 6. So in this case, we go all the way to the top. This is a long one. We've solved this and we've actually got 2 x values. So this works. So when we input x into here, if we input x is 0 into here and here, do a substitution, that would equal 5. And the other one, the other solution, is x is equal to a 6. So if we substitute a 6 into here, this would also work because the answer should equal 5. Okay, a few more examples to look at then. Let's have a look at these. Now, you should be recognising these by now. We've looked at a couple of expressions like this. This is the difference of 2 squares. So if we were to solve this, let's simplify this by factorising. So x squared minus 16 can be factorised to x plus 4, x minus 4. And we can write the equals 0. Now we're almost at a similar point to before, where to get equals 0, this bracket must equal 0, or this bracket must equal 0. So I'm going to write that over here. Either x plus 4 equals 0, or x minus 4 equals 0. So x, if I move that 4 over, minus 4 from both sides, x is going to be equal to minus 4. And if I move this 4 over by adding 4 to both sides, x is equal to 4. So we've got 2 solutions here. And again, if we substitute it in, we can check it works. Because minus 4 squared, minus 4 multiplied by minus 4 is 16. 16 minus 16 is 0. 4 squared is 16. 16 minus 16 is 0. So there's 2 solutions that work for this. Okay, so we've solved this one. Let's move over here. This looks like the difference of 2 squares, but you can't write 27 as a square term. And similarly, that this 3 cannot be written as a square term. So we must have to take out a common factor first. There is a common factor in 3 and 27, and that is 3. So I'm going to factor that out. 3 multiplied by x squared is 3x squared, and 3 multiplied by minus 9 is minus 27. So I'm going to equal that to 0. Now, this looks familiar. This is the difference of 2 squares. So 3 multiplied by x plus 3 and x minus 3 will be equal to 0. I've just factorised that out. Now we're at the same process as we were above. When we multiply these 3 expressions, if you like, together, the answer will be equal to 0. So one of them will need to be equal to 0. Now we can forget about that 3 because 3 is just a constant. So 3 isn't going to be equal to 0 because it hasn't got a variable that we can make into 0. It's just 3. So I'm going to ignore that 3 for the time being and just think about the 2 brackets. As one of the brackets is going to be equal to 0, or both of them could be equal to 0. So x plus 3 is equal to 0, and x minus 3 is equal to 0. So if I move the 3 over and minus 3 from both sides, x is equal to minus 3. And over here, if I add 3 to both sides, x is going to be equal to 3. So again, I've got 2 solutions here, which you can check and substitute in and make sure it works. Now, some of you may be quite confident in working from the bracket form. So spotting that for this bracket, x must be equal to minus 4, and from this bracket, x must be equal to 4. And same down here, from this bracket, x must be equal to minus 3, and from this bracket, x must be equal to 3. You can think about it as, for this one, minus 4 add 4 is 0, and for this one here, 4 minus 4 is equal to 0. So you might be able to spot it and not do this step of working. Some people spot that it's just a sign change. So x is going to be equal to not positive 4, negative 4. And for this one, x is going to be equal to 4, not negative 4. So let's have a look at some more then. So I'm actually just going to spot this now. So x minus 3 is either equal to 0. So x must be equal to 3, because 3 minus 3 is 0. And for this one, x minus 4 could be equal to 0. So x is going to be 4, because 4 minus 4 is 0. Let's have a look at this one. X minus 2 multiplied by x plus 3 is 0. So again, for this bracket to be 0, x must equal 2. And for this bracket to be 0, x must equal minus 3. Let's go over here. We've got a slightly more technical case. So I am going to write these ones out. So 2x minus 1 could be equal to 0, or 3x plus 2 could be equal to 0. So let's move the 1 over, add 1 to both sides. 2x is equal to 1. And then divide both sides by 2. X is going to be equal to a half. Over here, move the 2 over, so 3x is equal to minus 2. And then divide by 3 on both sides, we're going to have minus 2/3. So great if you can spot it from here. Otherwise, you can write this out. I think of it mentally, so I would think, right, this is negative, so it's going to be a positive. X is equal to positive, and then I'm just going to divide that 1 by 2. Here, there's a positive, so x is going to be equal to a negative. And again, this 2 needs to be divided by 3. So whatever suits you. So I've got the answers there. Let's move on to the next one then, and have a look at x squared minus 7x plus 10 is equal to 0. So here, it's not very easy to work with. So if we can get it into this form, where it's written as a product of its factors, then we can solve this. So we need to solve this quadratic by factorising, if you like. So let's factorise. I'm going to have x here and x here. And then I need to think about the factors of 10, which will make minus 7x. Well, 5 and 2 will work quite nicely, so I'm going to put a 5 here and a 2 here. This needs to be negative, and this needs to be positive. So in order to get a minus 7x, they both need to be minus. And we'll still get a positive 10, because minus 5 multiplied by minus 2 is 10. So let's equal it to 0, and then we're back to something similar above. So again, x must equal 5 for that bracket to be 0. 5 minus 5 is 0. And x must equal 2 for this bracket to be 0. 2 minus 2 is 0. Let's do this one. Slightly more challenging, because we've got a coefficient different to 1 here. So I'm going to have 2 brackets still, equal to 0, but we're going to have a 2x in one and an x in the other. So think about what we need to have here. Well, we could have 6 and 1 as factors of 6, or 2 and 3 as factors of 6, but we need to get a positive 1x. So we just need to think about it a little bit. If I put a 2 here and a 3 here, that's going to make 4x, and then we've got a 3x. So the difference between those would be an x, and I need a negative 6. So one's going to be positive, one's going to be negative, which does work. So let's put a positive there, a negative there. And then that would actually, when we expand it, get back to this expression. So now 2x minus 3 is equal to 0, or x plus 2 is equal to 0, or both. So let's do this one first because this one's nice. X is going to be equal to minus 2. And then this one, again, you can set it out like this above. I'm just going to think about it. X is going to be equal to, now it's going to be positive, and the 3 is going to be divided by 2. So 3 over 2. Alright. 2 more examples to go, and then you're going to be completing some questions. So on these ones, we don't necessarily need to go ahead and expand this out. Remember, this is a bracket squared, and normally it can be rewritten as x minus 2 and then another x minus 2. But for this one, we can just actually do the opposite of squaring. So this side's squared, so in order to undo that, I can just square root both sides. So if you think about it, the square root of x minus 2 squared, well, these are opposites. So actually, they're going to cancel. So I'm going to be left with x minus 2 on this side. And then I just need to think about that. I'm going to have the square root of 3. Now, whenever you're initiating the square root, we need to be careful because you can actually have a positive or a negative answer. I'm just going to show you with a better example. So if I was to do the square root of 16, most of you would think, right, that's 4. Because 4 times 4 is 16. But there's also a negative answer, because the square root of 16 can be equal to minus 4. Because minus 4 multiplied by minus 4 is positive 16. So how we would write it is we would write it as plus or minus 4. Or we don't even have to get to that stage. Like we're doing over here, I could just say positive or minus 16. Okay, root 16. So that's what I've done with the root 3. Now, the root 3, we'll see more of this when we come across surds, but the root 3 isn't a nice number. Okay, if we do the square root of 3, it's not going to be like the square root of 16 was. It's not going to be an integer. So I'm going to leave it in root form. And I'm going to work with the rest. So I'm going to have to add 2 to both sides. X is equal to 2 plus or minus root 3. Now you could have wrote it as x is equal to plus or minus root 3. Add 2, that's exactly the same. Now I'm going to get 2 solutions here because I've got this plus and minus. So one of the solutions is going to be 2 plus root 3, and another one is going to be 2 minus root 3. Okay? We can leave it as this. We don't have to go ahead to this because this shows that there's going to be 2 solutions with this plus and minus. If you've never seen this before, don't worry too much because we cover this again in the next chapter. It's just like a nice introduction for you. So again, instead of expanding this all out and getting to a quadratic that could be complicated and then trying to factorize or solve it, I'm actually just going to work with the simplified form here. This side's squared, so I'm going to do the opposite by square rooting. Something squared and something square rooted is going to cancel. So I'm going to be left with 3x plus 2 is equal to the square root of 5. So now I'm going to move this 2 over. Look, I've nearly forgot myself. Plus or minus, remember, because we are initiating the square root. And when we do the square root of 5, we can have a positive or a negative answer. So, minusing 2 from both sides, I'm going to have minus 2 plus or minus the square root of 5. This one's a little bit more complex because we haven't finished just yet. We've got a 3x, so we need to divide both sides by 3. So minus 2 plus or minus root 5 over 3. And again, we've got two solutions here because one will be x is equal to minus 2 plus root 5 over 3. That was a dodgy 5. And then x is equal to minus 2 minus root 5 over 3. Okay, and again we can just leave it as this because you can see there's two solutions with the plus and minus sign. Okay, I want you to pause the video and have a go at these questions. This will be the end of this video once you've completed these questions. These actually appear in your notes.